All right. So we're talking about negative identities, and the negative identities are things we have talked about but never officially used this term. So negative identities fall into two buckets. So the first is even. You have two types of functions, as you know, even and odd. So the even trig functions we talked about were cosine of x and secant of x. And then the odd ones, the odd functions are sine of x, tangent of x, cosecant of x, and cotangent of x. And we talked about how for even functions, cosine of x equals cosine of negative x, and secant of x equals secant of negative x. And just what that means is if I plug in like 3 here, for example, and negative 3 here, the y values will be the same. They will not change. Okay. Same thing for secant. If I plug in 3 here and negative 3 here, y values will stay the same. Odd functions, however, do not have that property. Odd functions have the property that sine of x equals negative sine of negative x. Tangent equals negative tan negative x. Cosecant equals negative cosecant of negative x. Cotangent equals negative cotangent of negative x. What we mean by here is when I plug in 3 and negative 3, I get opposite y values. That's what this negative sign out here indicates. Here we don't have that extra negative, so we get the same thing when I plug in 3 and negative 3. Here we get the opposite thing when I plug in 3 and negative 3. Any questions on this broadly before we dive in? How do we use this? So let's do some example problems. So the first problem I want to do is on page 2, problem number 3. Page 2, problem 3. So problem 3 reads, part 4, top of the page. Sine of alpha plus 3 cos negative alpha minus 4 sine negative alpha plus cotangent of negative 2 theta plus cosine of theta. Why do I keep saying theta? This is not theta. This is the Greek letter alpha, not theta. Sorry. So used to saying that. So the goal here is, and although the directions aren't necessarily specified, it's just to simplify the function. That's it. Simplify the function. And get rid of these negative angles in here. So I'll start with this first angle right here. So this says 3 cosine negative theta. So how could I rewrite that? Well, I know that cosine of negative theta equals cosine of positive theta. So instead of writing 3 cosine of negative theta, I could write 3 cosine of positive theta. So nothing else changes. I'm just doing one step at a time. The sine of theta, alpha, plus 3 cosine of, not negative alpha, but just alpha. So the negative almost just drops away. And I'm not going to change anything else. I'm going to do this one step at a time. And the reason I'm doing this is partially because I don't want people to make mistakes. I think it's better to just take things slowly and do one at a time. And the other thing is, I was noticing on the quiz when I graded it, a lot of people did very poorly, and when I looked at their multiple choice work, they weren't doing the steps that I do. It doesn't make any sense to me. So I'm trying to be more deliberate about the steps. Something. Where? Yeah. Here? No, your red one. This is a 3. That's an alpha. So now I can combine these. They both have a cosine of alpha. So what am I going to get? Well, I'm not changing anything else. So sine theta alpha plus 3 plus 1, 4 cosine of alpha minus 4 sine alpha plus cotangent of negative 2 alpha. By the way, this Greek letter alpha will come up if you take stats next year. We call this significance level, but you will see this later on.
That negative alpha?
Where?
Or negative 4 sine?
Absolutely right. Thank you, Brandon. Negative alpha. Very good. All right. So the next thing I want to deal with is this right here. Remember, the goal is to get rid of these negative alphas. Mariah, question? Talking about something that's not related to pre-cal?
No, I'm saying
Oh, she answered it for you. Very good. So, again, I'm not going to touch anything else. I'm going to leave this here. But this time, we have something very interesting happening. This is 4 sine of negative alpha. So, because sine is an odd function, we cannot just drop the negative away. Instead, we need to basically bring this negative out here. And the reason we do this is because sine of negative theta does not equal sine of theta. Sine of negative theta equals negative sine of regular theta. The negative comes outside. We showed that way back here. The negatives come outside. So instead of this being negative 4 sine of negative theta, we just write it as positive 4 sine alpha. What I'm saying, I'm so stupid. Negative times negative is a positive. And then, of course, we have the cotangent, which we haven't even touched yet. Negative 2 alpha. But the key is this negative comes outside. Negative times negative is positive. The reason being, this is an odd function. And the last piece I'm going to handle is this right here. The last piece. Oh, before I do that. Well, now that I've underlined it, let me just do that. So, sine alpha plus 4 cosine of alpha plus 4 sine of alpha plus cotangent. But what should I do here? Cotangent is odd. This needs to come outside, so this should be minus cotangent of 2 alpha. Cotangent is an odd function. The negative needs to come outside. And the final step is these can be combined. So what is my final answer? 5 sine of alpha plus 4 minus cotangent 2 alpha. And there is your final answer. Suddenly.
If that equation is the same thing as the first equation, why was it written like the first equation?
Because we want you to make it show us what it looks like.
So then you would never really see it the other way?
No. You're right. Like, we'll never give you this and be like, make it look messy. Alright, so questions on that one? Okay. Yeah. Alright, so I'm going to number 4 now. With number 4, I want you all to attempt a lot of this one on your own. You don't really necessarily need me the whole time, but I would love for people to attempt and begin checking up here as they go along. Alright, so this is the first thing I'm going to do, what's in this pink box. I'm going to freeze the camera, and I'll open it up here very shortly to show you what I got. So here's what I got, just doing one step. Alright. The next step I'm going to do is what is underlined in green. So here's just focusing on the green. Gonna combine these now. I notice that the oranges are the same. What happened? Oh, yeah, you're right. I forget to freeze it. I guess I'm hoping people will be honest and not look up. And then one last step. I'm gonna focus on the yellow. And there's your final answer. I'll stop here and see if there are questions before I go on to the next problem. That's what I'm going to do. Abraham. Why is it not supposed to be adding? Someone answer his question. Abel?
Because on the inside of theta, it's still the same thing as regular secant.
Why is that, Abel?
Because they're both even functions.
Yep, secant is an even function. Very good. More questions? Okay. All right. Let me go to number 7. Still level 2. Sorry, still part 4, but now level 2. Number 7 says sine squared negative x times cosecant of x plus tan squared of x times cotangent of negative x.